In this video, we're going to look at another way to find volumes known as the disk method. All right, so what we're going to try to do is we're going to take regions now instead of piling on like the same cross-section shapes. What we're going to do is take this region and rotate it around an axis. So what we do is we have y equals x squared. From 0 to 2 is going to be this region here. All right, so if I were to rotate that around the x-axis, all of these are going to rotate around. And it's going to create a shape that kind of looks like this. Now you can kind of think about it. It's almost like a funnel, except for it's solid all the way through because we're rotating a solid region. All right, so that's going to be the kind of shapes that we're talking about. All right, taking this region and rotating it around the x-axis. All right, look at calc textbooks and things. They can always draw better than I can, but that's the basic idea. What happens if I rotate it around the y-axis? All right, same region. Now I'm going to rotate these things around the y-axis, and you can see there's going to be kind of this gap in the middle. All right, so it'll look something like this. All right, so it's like a funnel in a sense that there actually is a gap in the middle, and then all the outside parts are filled in. All right, so the strategy for these is we're still looking at cross sections, and if we're rotating something, if we start with a kind of a region and we rotate it around, you see we're going to get a circle. All right, when you rotate something, you get a circle. So our formula, just like our previous cross section one, if all the cross sections are circles, well, the area of a circle is pi r squared. And what the radius is going to be, the radius is going to be that kind of initial height of our region that we rotated around. So our r is whatever our function is, and then it's pi r squared. Right, so the formula looks really complicated. There's a pi and there's a squared, but if you think about it, you're basically just adding up a bunch of circles. So adding up things is an integral, and circles have area pi r squared. All right, so that's where this formula is coming from. Again, in this video, we're mainly going to focus on creating the equations, right, rather than actually solving them all by hand, but it is possible to solve them by hand. All right, so find the volume of the solid. That results when the region between the curve y equals x and the x-axis. All right, so this is going to be y equals x, x equals 1. We have this region. And this is actually just going to give us a cone, because when we rotate it around, it'll have a point at the end, and it's going to be a solid cone. All right, but the formula is going to be adding up from 0 to 1. All right, it's pi times r squared. And what's the radius? The radius is this height of each of these things here, which is x. Right, so that is the integral that we create. All right, the integral from 0 to 1 of pi r squared, knowing that our radius is this changing function x. And then just this one is the one you could definitely just solve by hand, but I'm just going to have the computer do it. And you get 1.047. Again, this video, I'm going to mainly focus on creating the equation rather than actually solving it by hand. All right, what is the volume of the solid generated when the region bounded by the graph y equals x squared? The vertical line, so let's just start drawing this stuff. Y equals x squared is parabola. X equals 3 is here. The horizontal line, y equals 4. All right, and that's going to give us this region here. And we want to rotate that around the horizontal line, y equals 4. So this thing doesn't always rotate around an axis. Here we're going to rotate this piece around, so we're going to get something that looks like that, doubled with a bunch of circles. All right, so it's kind of like a solid bowl is what we're going to end up getting. All right, but the same thing, we're going to start our integral at where our thing starts at 0, and it ends at the vertical line 3. And then pi r squared. We just need to figure out what is our radius. Our radius is the distance from 4 to the red line. So just like when we're doing areas between curves, it's going to be 4 minus x squared. All right, so we want to take all this 4 and subtract off the part we don't want, which is the x squared part. All right, so this is going to be our full integral. And just to get an idea of what the answer is going to be, let's just type this in a calculator. 0 to 3 pi times 4 minus x squared dx, and we get 77.28. So that's the volume of this solid. But again, just thinking about it, where does your integral start and stop? And what is the radius? All right, think about the radius in relation to where you're rotating. Here we have the region bounded by the curve x equals 4 minus y squared, and we're rotating about the y-axis. So again, 4 minus x squared, or sorry, 4 minus y squared, because now we're having y be the variable. This is the sideways parabola going this way. All right, we're just doing the first quadrant, so we're just here. I'm going to rotate about the y-axis, so we're rotating things this way. We're going to get all these kind of circles here. But just going in the y direction, now we're thinking our integral starts at 0. It ends at the y value where that crosses the y-axis, which is going to be 2 pi. What is the radius going to be? The radius is going to be just the distance from here to there, so that's our equation. Squared. All right, so that is the same thing. All right, where you start and where you finish, and then pi times your radius squared. All right, so when you think about it in those terms, it's just like a circle, and just like finding the area of a cylinder. All right, just that your radius is changing based on whatever equation you have. All right, in this case, you get the volume is 53.617. All right, so again, for this video, mainly focus on your understanding how to create the equation. If we wanted to solve these by hand, we could. It would just take a while. All right, so here's one for you to try on your own. All right, the volume of the solid generated by y equals 2x, the x-axis, and the vertical line x equals 3 is revolved about the x-axis. All right, so go ahead and try that one on your own. And the answer that you get is 113.097. But again, focusing on the important parts, right, our area starts at 0 and ends at x equals 3. Right, pi r squared, and what's the radius of the things we're rotating? The radius is 2x. All right, so just putting that into our equation. Again, this is one you could definitely solve by hand, but calculator gives me 113.097.